the next video or two, I'm going to show you how to create a skill web in Python Tkinter. To prepare for that, this video will cover the theory and math behind N-gons and how they relate to skill webs. By the end, you'll understand how to draw any N-gon programmatically, which is the foundation for building a skill web. An N-gon is a polygon where N stands for the number of vertices and edges the shape has. For example, we have the octagon with 8 vertices and edges, the heptagon with 7, hexagon with 6, pentagon with 5, the quadgon or quadrilateral with 4, and the smallest, the trigon or triangle with 3. We're using N-gons because skill webs are shaped like polygons. Let me show you an example of the skill web I referenced while coding this project. You'll notice that 1, the skill web forms an octagon with 8 vertices and 8 edges. 2, there are multiple smaller octagons nested inside of the larger one. And 3, each vertex connects to a skill. And since there are 8 skills, the shape is an octagon. This means that the number of skills you have will determine the type of N-gon you draw. For example, 10 skills will get you a decagon, and 3 skills will get you a triangle. Remember, polygons require at least 3 vertices and edges to form an enclosed shape. So a trigon is the smallest N-gon you can make. Anything less than that will cause the skill web to look weird. Okay, so let me show you how to draw N-gons in Python Tkinter programmatically. The following code creates a window for our project. In order to draw something in Tkinter, you need to initialize a canvas first. Initializing the canvas isn't enough though, we also have to display it. Now we have to define an imaginary circle for our N-gon by setting its radius and center. By doing this, we're making it where the N-gon is inscribed inside of the circle. All this means is that the N-gon's vertices are going to be touching the circle. We're doing this to make sure that the N-gon vertices are equally spaced apart and are equal distance from the center. Okay, so let's make the center of the circle the center of the canvas. First, we have to update the canvas so we can get the right dimensions. Next, we'll actually set the canvas width and height. Now we'll get the center by dividing the width and height by 2. You can set the radius to whatever number you want. The bigger the radius, the larger your N-gon will be. The next step is to calculate the vertex angle. We need this so that we can calculate the exact position for each N-gon vertex. Remember, we are inscribing our N-gon inside of an imaginary circle. So the total angle of a circle is 360 degrees or 2 pi radians. To calculate the vertex angle, we can either do 360 degrees divided by n, or we can do 2 pi divided by n radians. We're going to use the latter, but first we have to import the math module. Now we set what kind of N-gon we want to create. Finally, we calculate the vertex angle. Now all there is to do is calculate the N-gon vertices and then draw the entire N-gon. As we calculate the coordinates for each vertex, we're going to have to store them in a list. Remember that the n in N-gon represents the number of vertices the polygon has. So we can just pass self.ngon into range and then use that to iterate through each vertex. Now we have to calculate the angle for the current vertex. Next, we calculate the vertex's coordinates starting with x. Because we are inscribing the N-gon inside of an imaginary circle, all of its vertices are going to be on the circle. But to begin with, we're going to have the vertices start in the middle of the circle. The radius of a circle is the distance from the middle of the circle to any point that's actually on the circle. By adding the radius to self.center_x, we are moving the current vertex to the edge of the circle horizontally. It's not in the right spot yet, but at least we're getting closer. To get the correct horizontal position, we are going to multiply x by cosine and pass in the angle for the current vertex. The same goes for the vertex's y, except we use center_y and sine. Now we add the coordinates to the end of the vertices list. Then we finally draw the N-gon. The type of N-gon you draw is dependent on what you put for self.ngon. The last thing we have to do for the N-gon is rotate it. If you look at this triangle, you'll notice that its tip is rotated to the left a bit. This occurs with all odd N-gons. If you're watching this so you have a better understanding of the upcoming skill web tutorials, you'll probably think it looks better like this. So let's go ahead and handle this. The first thing we have to do is create an offset. Then we add the offset to the angle we calculate in draw_N-gon. Now all of our odd number N-gons are rotated. Alright, so that's pretty much it. So stay tuned for the upcoming skill web videos and thank you for watching.